We're going to talk about your 2-1 notes, which is solving one-step equation guided notes. This is page 1 in your Unit 2 packet of papers. So first we want to get into a little bit of background of equations. So an equation is a mathematical sentence with an equal sign. We talked about that back in Unit 1, your very first lesson. An equation has to have an equal sign. Most of these sentences, most of these equations are going to have 4 main components to them. They're going to have a variable. They're going to have some type of an operator. This is your plus, your minus, your multiply, that kind of stuff. They're going to have a coefficient. Remember, the coefficient is the number in front of your variable. And they're going to have a constant. That's your number that's not attached to the variable. That's kind of by itself. In the next part, it says, what's the difference between an expression and an equation? An expression does not have an equal sign. An equation must have an equal sign. So there's your difference. That's how you can tell if it's an expression or an equation. An expression does not have an equal sign, and an equation does. So I want you to try this next part, part C, here on your own first. It says circle the equations. So go through, if this is an equation, you would circle it. If this is an equation, you would circle it, so on and so forth. And you're going to box the expressions. So if this is an expression, you would box it. If this is an expression, you would box it. It can't be both. It's either one or the other. So all 4 of these should either be circled or boxed. Okay, so try them on your own. Pause the video, and then when you're done, come back and we can do it together. All right, so each one of these should already be boxed or circled. You should have done that on your own. So we're going to go through and circle our equations and box our expressions. So this first one here, because of this equal sign, that is an equation, so I'm going to circle that. The next one, there's not an equal sign, so that's an expression. I'm going to box that. The next one, also no equal sign, so we are going to box that one. And then the last one has an equal sign, so I'm going to circle that one. All right, part D. A solution of an equation is a value of a variable that makes an equation true. A solution is a value for the variable that makes your equation true. So back up here, there's a specific value that you could plug in for x to make this entire left side equal 8. That would be your solution. So you can substitute a number for a variable to determine whether the number is a solution of the equation. So we're going to do these couple of examples. We're going to do a couple together, and then I want to have you try a couple on your own. So we're going to decide whether or not the given value is a solution to these equations. And you're going to make sure you show your work to see how you got there. So to be a solution, we're going to plug it in for our variable and see if our equation is true. So I have 70 plus x equals 200. We want to know if 30 is the solution. So in order to do that, we're going to take 170 plus, we're given that x is maybe 30. We're going to find out. So we're going to see, does 170 plus 30 equal 200? So this is where, pause this video for a moment and open up Desmos. If you don't have that tab open up, you're going to want it. And then once you get it open, I want you to type in 170 plus 30. So pause this video if you need to get Desmos open and to do that. You're going to do 170 plus 30 in Desmos, or if you already know it on your own or you can work it out, that's great. Either any of those options. So when you do 170 plus 30, you should have gotten 200. So I have 200 equals 200. So the question is x equals 30 a solution? The answer would be yes, because 200 does in fact equal 200. Now we're going to come over here to this next one. We're going to see if 3 is equal to 12 minus a for when a equals 6. So we're going to see if a equaling 6 is that solution. So I'm going to see if 3 is equal to 12 minus 6. So let's see if 6 is the solution to this equation. So I just have 3. And then I'm going to figure out what 12 minus 6 is. So once again, either work it out on your own, do it in your head, use Desmos, whatever you need. Pause this video if you need some time to figure it out. 12 minus 6 is 6. Does 3 equal 6? No, it does not, which means 6 is not the solution to that equation. There is some different number that you would plug in for a to make that equation true. Now I want you to try these two on your own. Okay? Try them out, see what you get, pause the video, come back when you're done or if you get stuck. Alright, in this one we're going to see if 26 over 3 minus m equals 8 over 3. And we're going to see if m equals 6 is the solution. So we're going to keep our 26 over 3 minus, and we're going to plug in the 6 for m, equaling 8 over 3. Use Desmos, and then since we already have a fraction, make sure you turn this left side into a fraction once you've done that on Desmos. You should have gotten that 26 over 3 is 8 over 3, and 8 over 3 is equal to 8 over 3, so yes, m equals 6 is the solution. And then in your last one, 8 plus t equals 2t. We're going to see if t equals 3 is the solution. So we're going to do 8 plus 3 equaling 2 times 3. Remember, a number right next to a letter is our multiplication. And there were two places we had to plug that value in for t. We had to plug it in over here on the left and over here on the right. And we're going to do both sides. 8 plus 3 is 11. And 2 times 3 is 6. So is t equal 3 the solution? No, it is not. There is some different number that you could plug in for t to make it true. Now we're going to get into some solving. So if I give you a possible answer to be the solution like we just saw, then you can just plug it in. But other times I'm going to give you an equation, I'm going to just ask you, well, what is the solution? And in order to do that, you're going to solve your equation. So when you solve equations, there are 3 important things to remember. The first thing is when you solve an equation, your goal is to get the variable. Your goal is to get the variable alone by itself on one side of the equation. In other words, you are trying to isolate the variable, so that you want on just one side of your equal sign to be the variable and on the other side to be a number. When you are solving for a variable, you must use inverse operations. Inverse basically means opposite. Opposite operations. So when we're doing this, if I have addition, what is the inverse operation to addition? What is the opposite of addition? Well, that would be subtraction. So addition and subtraction are inverses. What is the inverse to division? Well, that would be multiplication. Multiplication and division are inverses. So if you have addition, you would solve by doing subtraction. If you had multiplication, you would solve by doing the inverse of division. The next part says, whatever you do to one side of the equation, you must do to the other side of the equation as well. In other words, you must keep the equation balanced or equal. That's why we call it an equal sign. You have to keep the two sides equal. If you take something away from the left side of the equal sign, you've got to take it away from the right side. Keeping your equations balanced is very important. Often it's helpful to think of solving an equation like lifting weights. If you add or subtract weight to one side of your barbell, you must do the same to the other side in order to keep it balanced, or else you're going to tip yourself over. Next, part B says, remember when solving an equation, you must use an inverse operation to isolate the variable on one side of the equation. You must keep the equation balanced at all times. Part C, when you subtract something on both sides of the equation, that demonstrates the subtraction property of equality. When you add something to both sides, that demonstrates the addition property of equality. Same thing with your multiplication and with your division. They're the multiplication property of equality, the division property of equality, if you do it to both sides of your equation. You're going to pause at this point in your notes, and you're going to complete the first IXL assignment and then come back.